Now I invite Dr. Narayan Hegde. Dr. Hegde is with the BAIF Development Research Foundation in Pune in India, and he is also a fellow at the National Academy of Science and National Institute of Ecology in India. He has also been working on the boards of MS Swaminathan Research Foundation, Global Alliance for Livestock Veterinary Medicines at Edinburgh, UK, and with Children's Future India. So, Dr. Hegde, you have the floor.
Is it okay? Yeah. Good afternoon. I represent farmers in India. As you can see from this slide, we have over 130 million farmers. After them, about 87% of them are small and marginal holders. The marginal holder means less than 1 hectare with an average of 0.4 hectare holding. The small farmers are between 1 to 2 hectares with 1.4 hectares average holding. So for agriculture, for them is a basic source of livelihood because almost 60–70% of the farmers live in villages and 80% of them are in agriculture. As you can see, with small holding, they cannot survive. As a result, they also have livestock as source of supplementary income. You can see about 65 million farmers also own cattle, 39 million farmers own buffaloes, 33 million farmers own goat, sheep. These are the important livestock, mostly for milk and also meat. Cow is not for meat, buffaloes partly for milk and meat, beef, goat and sheep are mostly for meat. India, like China, our competition between food production and population growth, they have been competing each other. So we have challenge. By the year 2025, we are going to face a severe crisis about the shortage of pulses and oil seeds. So as a result, I'm emphasizing these are the vulnerable crops where India is importing today. We are self-sufficient in cereals, millets, but not in case of oil seeds and pulses. Indian agriculture contributes to the GDP to the extent of 15%. 65% of the people dependent on agriculture, but the income of this comes only from 14% of the GDP. This indicates how agriculture position is becoming weaker, and one of the reasons could be that agriculture in many states, you can see in the circle, has not been doing well. The farmers have been not performing well. We have poverty to the extent of 39% of the families in this country, in these states. And if you can see the color, which is desert, the agroecological zones, these are not very bad regions. They are fairly good. They are not desert. They have good water, good soil. In spite of that, they are poor. That indicates that there has been something missing with these small farmers. The important thing is the value chain missing. The farmers are illiterate, they are backward in the communication, and the value chain has been missing. So it indicates that when you deal with the small farmers, market development, value chain development, backward linkages are very important. So unless you achieve that, any technology you place, they may not be able to be advantageous to small farmers because good technologies are taken advantage by the rich farmers. So it's a very important issue to be noted that when you bring new technology, you need to address the facilitation of the backward-forward linkages. With that, I'm very proud that India has been taking good lead in biotechnology. Till 2000, biotechnology is biofertilizer, biopesticide, tissue culture. And we see great opportunity in agriculture, now the modern, with the introduction of GM crops in 2002, a lot of emphasis has been given on genetically modified crops. Along with that, molecular mapping of the important plants, marker genes for selection, development of transgenic crops, tissue culture, biofertilizer, biopesticide, vermicompost, decomposition of the waste, organic waste, mushroom production, and etc. With regard to transgenic crops, as every other country has been doing, our focus has been on increasing the yield, improvement in product quality, increase in nutritional value, reduction in biotic stress, tolerance to abiotic stress, and production of pharmaceuticals and medicinal herbs. With regard to GM crop, India has a distinct history and a story. In 2002, we started with 55,000 farmers with 30,000 hectares. First 2 years have been utter failure. There have been a lot of problems. Fortunately, the private sector, which has been managing, were able to address these issues. As a result, the technology got in. And the technology was so fast that even before government started monitoring, almost a majority of the farmers had already adopted GM crop, cotton crop. This indicates, very important note, that the private sector is very fast, and unless you have a very strong coping mechanism, in the government sector will not be able to control the damages which can take place. Anyway, continue the story. By 2014, India has been a GM crop with cotton. 96% of the area has been under GM. That means 100% replacement by the GM cotton. We have 1,100 varieties. As a result of introduction of GM crop, in the period from 2002 to 14, India from an importer became an exporter. From 13 million bales in 2002, in 2014, our production was 40 million, we have become exporters. Not only this, all the small farmers also adopted 100%, and there has been a very significant income benefit. 3 times more income could be harvested. So, as far as the production side is concerned, GM cotton is a success story in India. The dark side I will come a little later. As a result, today India is one of the 4th in the rank GM crop. I'm glad to say that we have surpassed China, at least in this sector, by having 11.6 million hectares, entirely cotton, only GM cotton, no other crop. And you can see, apart from once the GM crop was introduced, the GM oil, cotton oil, has gone into food system, oil cake has gone into cattle feed. In the year 2007, India started importing soybean, GM oil, canola, GM oil, for weedicide resistance. And in the year 2012, we imported worth $133 million of oil from various countries. Today, our income has been significantly high. We have $4 billion income from biotechnology industry. However, only 14% has come from agri-biotech. Only 14% is from agri-biotech. There are other applications which we are very proud of. Now, having done this, after the 2002, the Indian government became completely shy about the GM crop, and we have a series of studies going on. Only recently, in 2014, we were able to now again promote. We have been doing a lot of research, but we started research we have started some field trials in about 13 crops. You can see there are various purposes. Insect resistance, salinity resistance, herbicide resistance, and further we have also been taking up marker-resisted selection in case of black gram, other pulses, and in case of rice, saline tolerance, and brinjal has been a story which has not been approved. Simultaneously, we were also concerned, and the our aim has been to take up seed production by farmers, using the GM crop. This has been a serious concern. Now, with regard to the reasons why the government of India, in spite of success story of cotton, were resistant, because GM, although it has fulfilled the objective in controlling certain resistance to certain pests, it has been not resistant to other pests and diseases. In the case of cotton, there was a time when we saved pesticide on the bollworm, but the other suckling pesticide, we had to spend same volume of pesticide for the other crop. In many cases, the crop yields were low, the cost of seeds were very high. Dependence on seed companies is a major concern. We are really concerned that whether we have to buy seeds from the GM private companies instead of using our farm. This is a greater concern. There has been complete failure in transparency. The monitoring system has been very weak. Even today, we have been consuming GM oil, but we are still doubting, we have adequate studies have been conducted about the safety of the health. This is a big question. And this is one of the most important reasons. And transparency and very few monopoly private multinational companies have been dictating. So it's a very dangerous term. We feel that a lot of general public sector undertakings should be coming into as players so that there is no monopoly of the multinationals. This is the important concern for the resistance. We also have several fungicides, pesticides, which have been very well done, but there are lack of marketing like we have in GM crops. We have been, right now, fortunately, there are many branded fungicides, pesticides, which have been biologically produced. We have nematicides. And similarly, biofertilizer has been very well used. However, with the government of India effort, we have been producing almost 2.5 tons. There is a demand for 2.5 million tons. However, we have not been achieving it. We believe from the NGO sector, if we can give the same emphasis on biopesticides, biofertilizers, then the farmers will be much better off. This is where we lack the zeal and support. Tissue culture has been another good story. We have been carrying out tissue culture for various purposes. However, in the last 10 years, we have been very successful in commercializing various crop cultivation using tissue culture. In the last 3 years, you can see, we produced 1.6 billion to last year, 2014-15, we produced 1.9 billion plants, mainly for banana, sugarcane, strawberry, cardamom, aromatics, and ornamentals. We still see great hope for expanding this sector. What is important is when you deal with the new technology and for the focusing on the small farmers, it's extremely important to provide backward and forward integration. Need to have water conservation devices, efficient water use, new technologies, new systems. The crop has to be fitted in, linkage with the market. Empowerment of the women is a very important thing when you deal with small farmers. It's the women who work, and unless you train them, bring them as main front actors, the chances of getting the technology successful will be difficult. And finally, value chain is very important. Many times you have seen the technology has failed because we only deliver particular technology. There is no support for the backward integration nor for the market. So it should be an integral part if the technology has to be successful. With regard to livestock, we also have tremendous opportunity. As you can see, livestock is a very important source of livelihood for small farmers. India has already produced embryos of use of embryos for bull production, frozen embryos. We have produced, we have cloned female and male buffaloes. We have been using the technology for karyotyping, for screening against various genetic disorders. We have been looking for thermostable vaccine production. And we have also modern biogas plants because, we use the dung for cooking fuel wood. And using of the dung bio-waste properly for agriculture through biocomposting and vermicompost is a very important activity. Presently, we have taken up a series of studies, genomic studies to identify the positive traits of Indian native breeds of cows and buffaloes. This we intend to use it for marker-assisted selection of sires in the future. We have been the leaders in using frozen semen technology. My organization, we have been working with small farmers for the last 50 years using frozen semen technology. The services delivered at the doorstep of the small farmers. We are now planning to use sexed semen for producing only females because recently we have a ban on cow slaughter, so farmers are sentimental to send the animals, cattle to butchers. So we thought we must have only females so that they don't have to everything. 90% of the animals, cows born will be female. And that has been with the US technology we are starting this year. 2 minutes. There are a lot of vaccines that develop and also feed studies have been done. My colleagues will be presenting a lot of digestive studies. Very important study we would like to have is monitoring the methane production in the rumen system of the livestock. Almost 12% of the greenhouse gases are emitted by the livestock because they breathe, release methane. If we can control that bugs, bacteria, so that, you replace with something else, the methane generated will be suppressed, that energy will get into nutrient, that would improve the productivity of the animals. Now, this is the system how we take the technology to small farmers. This is we train the local youth in breeding. This is why the picture takes a motorcycle, frozen semen container, goes from house to house, talks to the women and the men who are dealing with the livestock. As a result, good quality crossbreeds, the technology has been demystified. It goes as an input with all the support services. As a result, the farmer has no difficulty in adopting it. Today, my organization covers almost 20% of the villages. We have 100,000 villages who are working with 5,000 young youth like this who are unemployed now. We have been breeding almost 5 million, 4 million animals every year. And as a result, the technology reaches the doorstep very easily. Our farmers produce milk. Our native cows have been producing 200 liters per lactation. With the improved breeding, crossbreeding, the milk yield is 2,500 liters per lactation, 12 times more. So with 3 cows, the families come out of poverty. On one hand, we have also 35%, 40% of families below the poverty line, and this technology makes them to come out of poverty with only 3 cows. So that is how this program has been. The message is technology, if you want to work for the small farmers, make sure that it reaches them. Secondly, when you deal with small farmers, country like India, they are semi-literate, they are poor, they are shy. Mentoring is a very important thing. We don't want us to blindly adopt like they adopted BT cotton. We want them to think, we want them to understand. We take the technology in the proper perspective so that they are not blindly following, carried away by the TV advertisements. They apply their mind, they realize the benefit. So this is my last slide. As everybody said, GM technology may be useful. We are not very I'm not very convinced whether the pesticide, weedicide-resistant gene is necessary. By introducing this, probably we will load a lot of pesticide, weedicide on our grounds. We will pollute one more pollution. So we have to be very, very careful to understand in the process of introducing a new variety GM crop, are we loading a lot of pesticide or weedicide or chemicals on the agriculture? So we need to have policy which is scientific evidence to convince that it's sustainable and beneficial. We need a resistance focus for more climate resilience, like drought tolerance, stress tolerance, salinity tolerance. Maybe they may be requiring in bigger proportion. We need equal emphasis on biofertilizers, biopesticides, and organic nutrients. Tissue culture is another thing. And when we go with the technology, facilitators and backward-forward linkages are very important. With that, I hope we take a rational decision. We don't be carried away by any one of the sides. Finally, we look to the interest of the small farmers and work for them. Thank you very much.